All right, and I think we are live. GM guys, thank you for joining today, where we get to talk about simplifying multi-chain developer experience with Axelar local environment. And then today we go through all the things you need to know. What are some of the developers' pain points, challenges, and also how can you fix it? And what are some of the simplest way to go about it? So, my name is Idris Olubisi. I am a software engineer and a technical writer, currently working as a developer advocate at Interrupt Lab, working on the Axelar network. And I'm really excited to have you here once again. Let's get right into it. So, what are we going to cover in this workshop? Well, first, we talk about multi-chain development. What are some of the things that have changed over time? And also, how we moved from the era of Ethereum and Bitcoin to the era of some of the changes that we've seen even within the interoperability space and some of the other key things that you need to know as a developer. And then we talk about common developer challenges. We also talk about the Axelar local development. What are some of the things you should look out for? Developer experience, how can we improve developer experience? Um, in as much you always talk about user experience. What about developer experience? Developers that are building, what are some of the things they should focus on? And also, what are some of the things they can quickly get up and running from their local development environment? And then we talk about the Axelar examples, where you see examples, we go through the examples that you can try out of the box. And finally, we talk about, we go through the live demo where we see all of these things in action. So I quickly want to pick a picture where I, get to talk about what it is for developers when they are trying to build an application and they want to test things locally. In fact, not just testing locally, but also doing things like automation tests, writing like end-to-end tests, force tests, and every other test that you could think of before a project could go on mainnet. So last month, a friend told me he was building a DeFi application that is needed to allow user to swap tokens between different chains. In his own scenario, he wanted to do this between Ethereum and Polygon. Yeah, that sounds straightforward, right? Well, he spent 3 days setting up different RPC nodes, managing multiple faucets, and waiting forever for testnet transaction. And then by day 4, he was already drowning in terminal windows and picking apart failed transaction across block explorers. That's quite funny, right? Because I don't know exactly what he's doing wrong, but then he hits me in a different way where you could imagine dealing with 4 or 5 chains. He's just building with 2 chains in his own example. What about if he wants to do things within like 4 or 5 chains, and also he wants to get his environment up and running before he push that project to mainnet? This is the reality most of our developers face doing like building their own cross-chain decentralized application today. And that's why we are here. We'll look at how Axelar local development environment lets you test cross-chain interaction on your local machine, where you don't have to wait for any testnet confirmation or juggle between like multiple faucets. And we know how hard faucets is to get these days, right? By the end of the workshop, you see how to turn that 3 days of my friend headache into a 10-minute setup where you can quickly get it up and running. Now, let's talk about multi-chain development. What does it mean? And then, in case you're hearing this for the first time, what are some of the things you should know? So, taking a look at this diagram in front of me, you can see like we have a lot of connectivity and a lot of chains, right? Look at how far we have come. Just a few years ago, when someone said blockchain, they mean Bitcoin or Ethereum, right? And then today we are looking at an ecosystem of hundreds of active chains. See Ethereum, see Polygon, see Base, Avalanche, Binance, Smart Chain, a lot more blockchains with their own strengths. But then why so many chains? To keep things simple, different chains have different superpowers. And then some prioritize speed, others security. Some are built specifically for gaming, and then others are built specifically for financial application. It's like specialized tool in your own toolbox, and then also within the ecosystem that you are most comfortable being part of, or like a community that you're part of. Taking something like Uniswap, it's not just Ethereum anymore. It's on every other chain like Optimism, Base, Polygon, and Ethereum and Ethereum. So why? Because that's where users are. People don't stick to one chain anymore. They want to go where the best app and opportunities are. They want people to see what their decentralized application can do, what are some of the benefits they can get leveraging their own application. And that's exactly what makes our job as a developer very, very interesting, because each change comes with its own setup, its own tool, its own tweaks, and some of the things that you should know before you start building with them. Building up an app that works across these chains is where it gets really tricky, because you have so many things to deal with, like I mentioned earlier, and also considering the fact that multi-chain ecosystem keeps growing and growing. And then growing means that user demands for cross-chain features, and also developers in the middle trying to make all of these things work seamlessly across chain. And we need a central point where we could connect all of this ecosystem easily. And that's where you think about Axelar, and then how Axelar is able to connect all of this ecosystem with single click. Yes, I mean it. When I say single click, I'm talking about making developer live experience very easy, having a function call that you can interact with directly to do what you want to do, and then not overwhelming the entire process. Like, don't have any overhead where you think about, oh, what are some of the things I need to build from ground up? You just leverage the existing SDK that we have available to you. And also you can just integrate it directly within your application. Either you are building directly on the front end, or you're building on the back end, which is front end in this case. I'm talking about like building interacting with the SDK via JavaScript or TypeScript application on the front end client side, or you are building a Solidity smart contract or a Rust contract where you want to interact with other ecosystem, but then via Axelar, making it easy for you to do all of that. But one thing to note is that developers have different, challenges, right? But I've created like common developer challenges here that I want to talk about here. So a few of them, as you can see on the screen, is number one is testing complexity. So managing multiple RPCs and networks simultaneously is not an easy task. Trust me, cross-chain transaction failure is also hard to replicate and debug, because now you are not just looking at one chain, you're talking about, maybe you have like two or three chains interaction. You want to debug on this chain, you want to know where things stand on this chain, and then you want to know how to move from one chain to another, and then what exactly might have gone wrong for the transaction to fail. So there's so many testing complexities. And another one is faucet. Yeah, faucet is very, very hard, because trust me, depending on the number of tests you have to make locally, you require faucet, right? Or sorry, the tests you have to make doesn't have to be local. Maybe, of course, if you need some faucets are usually for testnet environment testing, yeah. And all of these things, you need to get faucets, and then to make it work faster, or like to make your work easier and test all of the application that you want to test. But these days, faucet has become really hard to get, because you might even be able to get one, maybe 0.1, 0.2, or 1 at max. But then that might not be enough for the type of test or the type of application you're building. Another one is developer experience. With each blockchain having its own required, setup, tooling, and environment, the developer experience is kind of fragmented and inefficient, because you have to think of every use case and also everything that surrounds it, right? And then instead of focusing on building your own innovative decentralized application, developers spend significant time just setting up their own environment, and also making sure that they can debug with such environments, which could be like in a nightmare, which leads to my last point on the screen, where debugging becomes nightmare. Tracking messages across different multiple explorers, no unified way of monitoring this cross-chain transaction as you try to test them across different blockchains. Even if you try to go through the explorers are not always efficient when it comes to giving like the exact error. You can run into errors like execution reverted. That does not mean anything. Like to you, that does not really give context. Even though as an experienced developer, you might be used to that type of error. And when you see that type of error, you know what might have gone wrong. But I've seen cases where what I was thinking was not the problem. It was something different, right? But then that just gives you pointer, did not, but doesn't give you like exact place you need to look into and then what exactly is happening. Right. So these are common developer challenges that I know that everybody is aware of and which we can definitely, mitigate this type of challenge and then provide solutions to it. And that's where Axelar local development environment comes in, right? So when you're talking about Axelar developer local development, what exactly do you mean? So to keep things simple, this is a comprehensive toolkit that just simplifies cross-chain development supporting EVM chain, that's Ethereum virtual machine chains, and also other blockchain stacks like Aptos, Near, Sui, Cosmos, Multiverse X, with a pre-configured packages for seamless integration, which means that if I have this Axelar local development environment, I can be able to spin up something locally and also able to like interact with all of these different blockchain ecosystem locally without having to worry about things that I need to do with when it comes to like testnet integrations, at least for development purposes. And then this is what it looks like. This is a project. Like if you want to check it out, you can scan this QR code. It's going to redirect you to this project I'm talking about, and you can find more details there. So moving on to what are some additional things that you should know about Axelar local development. So core functionality. Yes, you have local blockchain network setup, cross-chain message passing simulation, and also instant transaction finality for testing. This is the most interesting part for me because I don't have to wait for anything. Everything just happens instantly. And if you have ever dealt with like interacting with different blockchain, because you need to consider finality on all of these chains when you are interacting with them. And that's a bottleneck because you have to wait. Let's say you have your development time for 24 hours. You spend majority of those time waiting for transaction to finalize, which you are not even sure if it's going to be successful or not. But when you have something that can give you instant finality on a local environment, you can quickly tell if this is going to fail or not. And then if it fails, you quickly write and then rebuild and retry again. You can see how cool that is. Another one I want to talk about is supported chains. The ecosystem has really grown, right? There's so many chains spinning up every now and then, right? Every day there's so many chains. But then the Axelar local development supports different chains, the EVM ecosystem generally, the non-EVM chains, Aptos, Near, Sui, and also the Cosmos ecosystem integration. So you can cut across, you can test within all of these supported chains. Now let's talk about development features. It is very easy because there's one thing for you to showcase how shiny a technology is. And also there's another thing for it to be seamless when it comes to integration or compatibility or giving that developer experience that we have always wanted. Yes, you can quickly set this up. It's quite easy to set up with just npm installation. During the demo session, I'm going to show you guys how we go through this process from scratch. Compatible with EtherJS, which are packages that you're already familiar with in the ecosystem. And it also have a built-in testing utility. So you don't need to worry about like maybe you need to go and look out for like testing tools that you want to use. It already have all of these testing utilities built in by default. So, but that's not all. Developer experience is important to us as a developer. Why we always talk about user experience. Everybody's talk about improving UX. But at the same time, we also need to think about developer experience and then what are some of the things available, the toolings available for them to have a great experience while building. Now, some of the things we should consider to improve developer experience, which Axelar local development environment allow you to do that with ease. Number one is zero wait time. You don't have to wait for anything, right? You just build, test, retry, build, test, retry, add more business logic, more interesting use case, test it instantly, build, and then retry. That's one of the fun parts of improving the developer experience because you don't have to wait. And also you have single terminal setup. Terminal setup is something that the developers are already used to, yeah. And over time, with just this project setup, you can have your terminal setup with all you need, and then you should be good to go to get started with any of the testing you want to do. And not just about terminal setup, but also simplifying the test process, which is the next point here, where you can simplify what exactly you want to test. And also, what are some of the things you want to test or write tests for? Another one is familiar tooling. All of the tooling used within the local environment are something you're already familiar with. So we have the Axelar example repo, which I'm going to get to, where it's built by, we have the hard hat configuration built there. So hard hat, if you're already familiar with that. And of course, we do have another example, which is particularly for Foundry lovers that you can try out under the Axelar example repo. But I'm going to tell you what Axelar examples are, and then what are some of the things you can do with it, because of course that's what we'll be using during our demo session. And aside that, we also have the final one there, which is the scalable beyond EVM. Yes, we know like the EVM community is quite big, but we also know some other ecosystem that are really active, which falls under the category of non-EVM environments. And all of these things you can test it directly within the Axelar examples that I'm about to go through. So I'll pause here a bit and see if we have any questions for now. Okay, yes, thank you guys for joining GM. All right, thank you. I think we are all clear for now. So now I mentioned like Axelar example, and I mentioned how integrations are built directly into the example. So let's take a look at what exactly is Axelar example. Yes, to keep things simple, Axelar example is a repository containing JavaScript and Solidity-based samples, dApps, that allow you to demonstrate and test cross-chain functionality using the Axelar local development environment. You can see how that connects into like the Axelar examples. So it's one thing for us to tell you Axelar local environment is great, or Axelar local development environment is really cool. It's another thing to showcase how cool it is and then what we can do with it today, which is why we created this robust repository that we've been constantly updating all this while. And this is for us to showcase what exactly you can do with some of this functionality that you can get out of the box integrating with Axelar local development environment. And you can find all of that within this repo. But one thing to note is that this repo focuses on how you can quickly test. But at the same time, while you try out all of these test commands like on your terminal, you can also check out some example integration, how those things were integrated, code samples, and some of the things that you might want to do on your own. So in case you don't want to directly use, like, of course, you have your own project, but then Axelar example showcases like some of these code snippets or how things are being done or tested. So you can also learn from that to build whatever application you are building and then test with that particular application. So this is also like what the quick screenshots look like. But the most important thing here is the QR code here that I'm leaving up for anybody to scan. And then it takes you directly to the Axelar example repository that you can try out. You can see a ton of activity going on here and there from different contributions from engineering team to DevRel team and also the DevX team. So scan this QR code or visit or just Google Axelar examples and you should find this repo as the top search. But that's not all. What exactly do we have within the Axelar example repo? Even though we'll be going through it like during the demo, but I feel like it's a very important thing to talk about it briefly during the walkthrough. Things to know is that we have the EVM examples demonstrating how cross-chain token transfer works, NFTs, and messaging. We also have the Cosmos and Multiverse example highlighting how you can test with non-EVM ecosystem or non-EVM cross-chain capabilities. All of these things embodied together within the Axelar example. But that's not all. We also have one interesting one that comes with like front-end integrations, which is the web examples. These are different folders within the Axelar example repository, and you'll be seeing them during this demo session. Please stay tuned. When we get there, you see all of these things in action. It's quite easy. It's quite easy to set up. It's very simple. We have guides that can allow you to set it up, and we all go through the guide together. So I mentioned Axelar example. Yeah, Axelar example is built with hard hat. So if you're already familiar with hard hat, that's cool. But then if you, in case you might have question around Foundry example, like Foundry is hot cake. Everybody's talking about Foundry and how cool it is. Yes, we also have Foundry example in case you want to try it out. And this is also the repo for that. You can scan this QR code, it takes you directly to the application, to the project repository rather. And you can see also not just being able to test on the command line, but see code snippets and also how these tests work and learn from it, or like see examples to also help you with your own testing, or like the project you're building on the side. So I mentioned messaging, yeah, and also talking about the Axelar local environment, the Axelar examples. I also mentioned like sending messages within chains, right? Everything within the Axelar ecosystem are built on the general message passing architecture. But it will be a good thing before we get to the example repo where we now do the live demo. I feel it's going to be really interesting for you to know what exactly messaging means, like what exactly is Axelar general message passing. So when you talk about general message passing, it's quite simple. Allow you to send message. This is a messaging layer that allow you to send message from one protocol to the other. But then as a developer, how is this useful to you? What are some of the things you need to know? The first one is the core contract function, and then the second one is the core contract with token. So these two functions are functions available to you to send message from one protocol to the other. So the first one, core contract with core contract, which is the first one here. First, you can see on my screen we have function call. We have two functions here. On the left, we have core contract. On the right, we have underscore execute. So on the left, we have the core contract function that you can call directly on your smart contract that will allow you to send message from one protocol. And there are a couple of things you need to pass in there. Number one is the destination chain. The second thing is the contract address of that you're interacting with. And then the third parameter here is the payload. So the first one is destination chain. In case you want to interact with, let's say you want to interact with base, for example, you can pass in destination chain base, and then the contract address on base, and then the payload. So payload here could be a string, an array, anything. Just think about it that you want to encode here on the destination, on the source chain. So if you're sending message from Ethereum to base, for example, all you just need to do is to trigger this function on source chain, which is Ethereum. And then the other one on my right hand side is the underscore execute function. This function gets triggered automatically on the destination chain once the message arrives on the destination chain, right? And then you can get access to the source chain where the data is coming from, the source address, and then the payload that was sent from the source chain. So you can embed, in case you have any functionality that you also want to include within this function. So what type of functionality am I talking about? Let's say you build an application and you want to send a proposal, for example, or like you want to send, let me use the bounty example. Let's say I want to share bounty to all my live viewers right now, and everyone submits their addresses. So what I'm going to do, if I'm going to send message to everyone, so The bounty example, of course, bounty is like gifting everyone, yeah. But in this case, I want to use it for messaging. I want to say hello world to all my live viewers right now. And then what I'm going to do is I'm going to collect like everyone's addresses where they can receive that particular message, and then encode it on the source chain here, and then send that message that I want to send, right? And then after sending it, once it lands on the destination chain, I can encode the function here, like decode the payload rather, to get all of the addresses and the message that I want to send, and then send it to all of these individual addresses. I know when I'm talking about the core contract we're talking to make even more sense to see like some of the use case that you can do with it. Let's say I want to send hello world to somebody, I can just trigger this function, and then once it lands here, I can also embed other things that I want to happen within this function. So the next one is core contract with token. So this is similar to what core contract does today. But if you pay attention to the parameters here, you see that we have even way more additional inputs like symbol and amount. So that's the difference between the core contract and core contract with token. Core contract with token allow you to send message and assets. Why core contract allow you to just send message. So in this case, let's say you have like different parameters. You can specify your destination chain contract address. You can also specify the payload, similar to how we did it when we talk about core contract, and then the symbol of the asset and also the amount that you want to distribute. So when you want to, now back to my bounty example, if I want to send anybody here any amount, and then when I try to send that bounty, I collected everybody's addresses, right? So when I'm going to embed under this other function called underscore execute with token, I'm going to embed like the distribution pattern for that particular asset that I'm sending. So that way I can calculate, oh, the addresses that was submitted is 20, and I'm sending 20 USDC. So 20 divided by 20, it means that everyone gets 1 USDC after dividing through, right? And I can embed that functionality here and then transfer to anyone. So the most important thing here is that what really matters is everyone gets like their token, and then how were they able to get the token. So I can disburse the token to any destination chain, irrespective of the destination. In as much the contract of distributing that token has been deployed on all those chains, then all of the addresses can receive assets on all the chains, all of their own favorite chains that they want to receive the assets on. So this is what general message passing is, and then the two functions are available to you. But to give you a picture of how this moves from one chain to the other, excuse me. To tell you how this moves from one chain to the other, the first one here, as you can see on the diagram on the left-hand side, is if this contract call is triggered by a decentralized application, it goes through the gateway, which is the gateway deployed for that particular chain. In this case, it's Ethereum, right? And then it emits an event which goes directly to the Axelar network. After validation and consensus is reached and a vote is passed, it goes directly to the gateway contract of the destination chain, where approved core contract is called. And this is to verify that yes, it has been approved on the gateway, and then it's good to go. It has been approved on the network and it's good to go. And then it goes back to the destination chain DApp, where the underscore execute function is being triggered. So for whatever logic that is embedded there, it gets triggered here, and then everyone is happy, right? So this is how the flow looks like, in case you want to like zoom out and see how does the interaction happen between chain A and chain B. I'll pause here a bit to see if we have any question before I proceed. Yeah, I can see one comment. Yes, a bounty is not a bad idea, actually. Yeah, thank you for that contribution. Yeah, but that's just an example anyways. Yeah, I see like we are clear right now. We don't have questions, but I would just proceed. So now the interesting part, which is the live demo, where we are all going to go through this together to see how you can do it. So what are we doing here? In case you just want to clone and then get ahead of things, please feel free to scan this QR code. It's going to take you to the demo that we are about to do right now. But then if you are coding along, like following along right now, you can, these are the things we want to do. First, we want to clone the Axelar example repo. We install the packages and spin up local blockchain environments. We test the screen for sending messages because we're talking about GMPs here. And then that's it. Yeah, if you are just joining, it's fine. It's totally fine. We can go through the examples together. So I'm going to navigate to my terminal and then try to zoom in a bit so that you guys can see my screen. Okay. Okay. Not sure if it's big enough, but then I'll keep zooming in. Let's see. I think I reached like the entire zoom. It's not working. Let's see something. Okay, yeah. So got it now. All right. So I think this is it. So what I'm going to do is we are all going to do this together. So I'm going to go back to. So this is the repo that I want to clone right now. And as you can see, this is Axelar example. And I can come here and just click and go back to this and type in clone. And what this is going to do is going to clone the entire project, which is what you would do if you are just cloning, for the first time, or you just want to try things out on your own. And after that, I can seed me into the example. Clear this terminal a bit. Yeah. I'm just trying to use the show I'm on the stable version of the NVM. Clear. All right. So now that we've cloned the project, I can click code to open the project before we start writing code. So you can see what it looks like. Oh yeah. So all right. So now we have the project. I can make this bigger so that you guys can see. So let me zoom in a bit. Yes. So this is what the project directly looks like. If you clone for the first time, this is what you're going to see. You find a lot of folders here, but you can see that we have like different folders for different things. And to make it easy for you, we have the example folder, and then the example folder contains like different folders. So we have the example folder, we have the examples web, and then we have the scripts and every other configuration here. But the most important thing, like where we'll be focusing more here, is Axelar, the examples folder, right? And then under the example folder, we have amplifier, we have Cosmos, we have EVM, we have multiverse, and then we have tests available to us, right? You can see we have different examples here. We have the amplifier example. If you are hearing amplifier for the first time, yeah, you can check it out. You'll see examples that you can try out. And then we have the Cosmos example. We have the EVM example, which is where we're focusing on here. So let me make this bigger. So one thing I want to call out here is that you can see all of these examples here. They are inside different folder, which means you can test directly within any of these examples, and you'll be good to go. So one thing is, let's get our project set up and running. So you can see the detailed instruction here, which we are going to follow together. We have cloning this project, we've done that. Click npm install and also run build to build the contract. So let's go back to our terminal and then click on npm install. This is going to install all of the packages that we need for us. So while this is installing, the next thing we want to do is to run build. So you can copy the command directly. So once this is done, you run the build and you should be good to go. Exactly. So now this is installed, and then I can run build to build the contract. You can see like it uses add hat, example, like add hat, environment to build the contract, remove existing artifacts if there's any, and then we build the contract from scratch. So now we've successfully built 117 solidity files, which are all the contracts that are available to you there. And then I can clear this. And now the next thing we want to do is to go back and see for us to run setup. So you need to set up like an environment variable. But why we have this is the Axelar example supports not just local development, but also testnet. But in this our workshop, we're focusing more on the local environment because we don't want to deal with different houses that I mentioned earlier on. But we still have the option if you want to try it out. So now we need to run this command, which is running the setup to get started quickly. Run the setup so that this command will create an environment variable for us and then copy things that we need there. So now let's go back to our terminal and then paste in that to run our setup. You can see it says generating random new random key, and it created the env for us. And then the next thing we want to do is, okay, if you maybe you run into issues or for some reason it's showing an error, you can also do a manual copy where you just do cp, and this will copy the environment example for you and then create a new file there. So now we can start our local blockchain, right? So what I'm going to do is to run start. And then you can see what is going on here. This is deploying all of the contract to different blockchain address. Right. I've not done anything. I did not impute anything. I didn't add my private key. I didn't do any of this. We can see that we have all of these things happening on the fly. We have Moonbeam, we have Avalanche, we have Phantom, we have Ethereum, we have Polygon in this example for local registration. And also for interchain token service, we have all of these 5 chain deployed. And then you can see it says serving 5 networks on port 8500. So which means I can interact with all of these 5 blockchain locally without anything, just manual interaction. One thing you should notice that this is the server that is currently up and running. If you want to continue testing, you should not stop this server. You should create a new terminal and then start all your tests there. So we have this caveat here that says that you should leave this node running on a separate terminal before testing that. So now that we want to test the dApp, and this is an example of testing it, so we can just copy this command and then go back to our terminal, duplicate the terminal. Okay, instead of doing this, let me just, so that we can know like the separate terminals, I can do this directly here, and then I can just clear nvm v18, and then we can run this. But in this case, I'm running for local, so I can just specify local. So let me close this so you guys can see my command. So I can just click just to be sure that everything is working fine. And as you can see, I'm just trying to check my balance here, right? I didn't have my private key. I'm just seeing what are some of the native tokens that are already created for me, which means I don't have to deal with faucet and all of those things. And what are some of the balances I have to try things out with locally? You can see all the balances, like this is a lot of money on my local environment, my wallet address that was spin off for me, and every other details. So I can clear this now. Now I'm going to move this down a bit and then open up this for us to start testing. But one thing to call out is that since I'll be focusing on EVM examples here, if you scroll down here, you see EVM instructions here, right? So under these, we have basic tests, we have the advanced tests that you can test out. They all have instruction on how to test them, so you shouldn't worry about it. So that should be quite easy for you. So after running that, now let's do something. Since we'll be under this directory, let's test out based on this instruction. So I'm going to go back to my Visual Studio Code now. And then the command says we should run npm-this to build the contract particularly for this, right? And that's what I'm going to do now. And this is going to do npm-CI and also run the build for us. So while this is installing, I'll see if we have any question. Oh yes, we can. Yeah, that's a very good question. Can't we run it on a Foundry framework? Yes, we can. Like I mentioned earlier during the presentation, we have the Axelar GMP Foundry environment. Yeah, Axelar GMP Foundry. So you Google it the way I just did. You see that we have it here, which is the Foundry examples that you can follow. Also contains that information and also deploying on multiple chains, right? So you can just clone, make call, and then start interacting. It also have like call contract example that you can try out. So because of time here, like there are a lot of things to try out. So focusing on the hard hat here, you can also try the same principle or like the same instruction, similar instruction follow because it follows the same pattern of the examples that we have already with the Foundry example. You just need to follow the instruction on the README and you can test. I would answer your question. So Claire, now that we've done the first part here, which is to be, so let's navigate into the folder for us to test. So the first test we want to do is to be able to like send message from one protocol to the other on our local environment, because now we have everything set up. We have our chain running, we have our local chain running, we have the environment variable that we named in this case up and running. So next thing we want to do is to test the application. And as you can see here, to test, you just CV into this and then run this command. That's for you to test. But the actual execution, this is what you need to do. So I'll just go straight to the example of how you should do it. So the first thing we want to run is this. So I want to deploy the contract. So what exactly is inside the contract? So let me paste this command here, but I'm not going to run it here. I want you guys to see what exactly we have here. So this is the contract. Yeah, and I'm going to open this. Let me bring this down a bit. So this is called the core contract solidity file, right? And then you can see that what we have inside it is this core contract, this Axelar, this contract that extends Axelar executable from the Axelar GMP XDK, right? And then we have all of these things already set up. So all you just need to do in this contract, what we are doing basically is to write a contract that can allow you to send a message from one protocol to the other. So the most important feature here is number one is setting the gas service and the gateway and the gas receiver. So which brings me to this other explanation of why do we need to set like gas service and gas receiver? A particular example here is if you want to send, let's say you want to send a message from Ethereum to Avalanche or Optimism, for example. You send the message from Ethereum, it goes through the Axelar network and then goes to destination chain. If you remember this diagram here, you can see this is the flow, right? It comes from the source chain and then goes through the Axelar network and go to the destination chain. This is chain one, this is chain two, this is chain three. In an ideal scenario, you're supposed to like pay gas for Ethereum, pay gas for Axelar network, and then pay gas for Base, because these are different networks that you're interacting with. But then we made it easy in such a way that you can, once you tell us the gateway and the gas service deploy for that gateway, we know what to do. All you just need to do is to pay gas once with the native currency of the source chain that you are currently interacting with. Let's say you are on Ethereum or you're on Base and you want to go from Base to like Optimism or Base to Avalanche. All you just need to do is to pay in the native currency for that particular protocol. And then gas payment for the Axelar network will be sorted, and also for the destination chain will be sorted automatically by the gas service. Right. Gas service plus other components that helps you make off-chain layer components that allow that to work automatically. So you don't have to worry about paying on the source chain, paying the Axelar network, and also paying on the destination chain. So now let me go back to the contract. And after that, we can see the function that allow you to send that particular message. The first, it takes in the destination chain, like I showed you in the demo. And then we have the destination address that you need to specify and then the message. You can see, make sure that yes, you have paid gas, like you added the gas, which is the default gas and the only gas you are paying for this call. And the next thing we did here is to encode this particular payload. And then encoding this payload means that after encoding, then you now call the gas service for that particular gateway and then pay for the contract call. and specify information like where, like this information is coming from, like the address, specify the address, which is the first entry, and then we are specifying this contract address. And then the second one is destination chain, where it is going to, the destination address on the destination chain, the payload, which is this payload that we encode, whatsoever message that we encode here, and then the message of sender. So this particular one, you might be wondering, like, why do we have to specify a message of sender? This is a parameter that is specified to receive any excess gas that you might have overpaid. So when you are testing with this application, you might be doing it maybe from the Explorer or trying to test on testnet locally, and then you enter random gas value, figure. So you're most likely going to have excess gas because probably the estimation is 0.0001, and then when you are testing, you just enter 0.01. So the leftover will be refunded to any address that you specified here. So even after the execution have ended, excess gas fee will be paid back because, of course, we want you to have a good experience and we don't want you to waste money. But another solution to that for you not to pay excess gas, even though you have this implementation, is if you are using our gas estimate SDK, our JS SDK to estimate gas, that is going to give you estimation of the required gas that is going to take you, depending on the specified network, on the source chain, and also on the destination chain. You get the actual value that you can now pass in before you make that call. So that way, you will even completely avoid overpaying, not to even get like refunded. Instead of overpaying, you just pay the exact amount and then you move on. And then the last function here is the execute function, where we have other informations that you need to pass in, like the command ID, the source chain, the source address, and the payload, right? So what I want to do next is, now that we know what contract we have here, let's go back to our terminal and see and deploy that particular contract. But before I do that, I'm going to let me make sure I seed into the examples, because that's where we are, and then I can now run this command and then deploy it locally. You can see we have this, so we've now deployed our contract locally, and then you can find all of the contract addresses deployed here. Cool, right? We have access to Moonbeam, Ethereum, Polygon, Avalanche, and Phantom right out of the box. So I can clear that and then go to the next thing to test our application, following the instruction here. So to test our application, to test this particular contract, we want to execute that core contract call. First, we entered the command to run execution, and then we tell it what we want it to execute, which is the AVM/core contract. That's the folder that we want you to execute, the contract we want you to execute. And then we also specify where, locally. Yes, we are not doing it on testnet, we want to execute locally. And also from which chain, what's the source chain, what's the destination chain. We specify Phantom as the source chain, specify Avalanche as the destination chain. And then finally, we pass in the message that we want to send. So I can decide to change it and say, oh, hello chain, yeah. Could be any message, right? And then we click enter. And that's what you need to do to initiate this. So it shows you that initially, the value at Avalanche is empty because Avalanche is yet to receive any message initially. The message value is empty until when we pass in this, until when the transaction is executed completely on the destination chain, and then we can now retrieve the value hello chain on Avalanche. How cool is that? Right? We're able to test this under a few seconds to test this interaction without, we already have the setup, the faucet setup. Normally, if you want to do this on testnet, you have to pay real money, like real faucet, and then go through and then wait for source chain finality, and then before the transaction gets completed. But right now, we can see all of these things happen out of the box. So this is the first example. Let's go to the second one that allow you to send with assets. So this is the second one that allows you to send with access. I will go to the README. It's similar to what we just did, but the difference is that we are now calling the EVM core contract folder, core contract with token folder. So now I'm going to go back to my terminal and then run this command to build the core contract with token locally, just like we did for core contract. And it's going to build the contract and then deploy it for us. Right. Now we have the contract deployed. What we need to do next is to run the execution of this contract. So this execution of this contract is slightly different because now we are not just sending message, but we are sending asset. So first thing I want you to note is npm run EVM executes core contract with token here. This is all specifying the execution and then which folder. And then we specify it's local. But in this case, we want to go from Avalanche to Phantom. And then we want to send 100 tokens. So let me change it to like maybe 10 tokens. And then we are sending it to this address. This is just to show you, this is an example of the address like that we want to send it to. And then we can click enter. So what this is going to do is to read the balance of that address on Phantom and tell us what the balance is before execution. And it's telling you that the balance has like 0 AUSDC. Confirm that the person is broke on Phantom, right? But now, after sending this money, this guy is super rich now on Phantom with 10 AUSDC with this address. You can see the details here, the same address. And then we have this address now has, 10 AUSDC. And you can see how cool it is for me to test both functions directly from the terminal without having to do anything extra. But it's also cool for us to look at, let me see, the folder and see what exactly is happening differently within the contract. Still similar contract with what we just did, but the major difference which I'm going to point to you is the send to many functions here that allow the system to send to that particular address. If you remember, during the presentation, I mentioned something around bounty. So this is another function that you can use to achieve that. This is a typical example for it. You can see here we have send to many. Sounds like sending to many people, as a bounty. And then where you can specify destination chain, destination address, and the destination addresses, which means that if you have like a couple of addresses that you want to fund on the destination chain, you can pass in all of these addresses here, pass in the symbol and the amount. But if you look at what is happening here, it's quite different from what we did when we wanted to make use of the core contract function. Address here, we specify like the symbol. We look for that particular token address symbol, get the token address itself, use the gateway token, the token addresses, look through the token addresses using the symbol, and then, so that we can get the exact token address for that particular symbol that was passed in. And then what we initiated is the token address transfer from the messenger sender to this contract address, the particular amount that was specified. And then we also approve the address. We also approve this address, the gateway token with the amount. And then finally, we encode the destination addresses here that was passed in here. And then we'll move on to pay gas. Which is paying gas is also similar to like the paying gas on core contract. Specify all the parameters, destination chain, destination address, the payload. The only thing is that now we have symbol and amount, and also the message of sender for any refunds that might happen after the transaction is executed. And then we call the core contract with token. So that's it. And then we have the other one for execute with token that now execute it. So if in a scenario of bounty here where we are sending to many, you can see here that we have when the code gets executed on the destination chain, we have the recipients available for us, which is all the addresses, and then we have the payload, the payload that was sent from the source chain, gets the token address for that payload, and then divide the amount to the recipients. You can see that we are assuming that you have more than one address here in the recipient. So we divide it and then transfer the amount, the sent amounts after division to individual recipients. And that's how we execute sending to multiple address. But in the example that we tested out right now, we tested with only one address. That's why you're saying that, oh, we only have one address here, and we're able to send 10 AUSDC to this address. You can keep going on and going. We have a lot more example that you might want to try out on your own. And also, in fact, ITS examples too that you might want to try out. So these are the two functions that we talk about during the presentation. But one cool thing I also want to include is the ITS functions. What are some of the functions that are available to you when you're testing with ITS, interchain token service? So I'm going to go through the interchain token service and then run 2 or 3 examples for you to see how to send only token, like particular token from one address to the other. So now let's go back to, we need to go back to our terminal now and then run this deploy script, just like you run every other script. Clear, and I'm going to close this. I'm going to bring this up a bit so you guys can see. And then I'm going to deploy the, and I need to specify if it's local or not. So, okay, I think, did I build example? Okay, let me try and execute directly. Maybe I don't need to build something. So this execution is quite different from the one we did earlier on. This execution is going to execute locally, send token from Phantom to Avalanche. Specifying source chain and destination chain, creating a token called my token with a symbol of MT, that's MT, and then you can see we have like all other details. Well, let's take a look at what those details are so we can get context of what we are doing right now. Let's look at what we did. ITN token service. Yeah, so now you can see here, I'm going to like bring this down a bit. So we can see all the parameters that we passed in. The first one is the name. The second one is the second one here is the symbol. The third one is decimal. The fourth one is the amount. And then the fifth one, okay, this one is passed in automatically. The fifth one here is the salt value, which are the parameters that we passed in here to test. So if you see the result, it says deploying interchain token, my token MT12 on Phantom, right? And then deploying remotely from Phantom to Avalanche. So initial balance is 0, sending 1234 token, amount of token to this, to Avalanche. That's from Phantom to Avalanche. And then after the entire process is completed, now we have the balance at Avalanche as 1234 from 0. You can see how this is another example of how you can test this thing directly from your terminal. And also, most important thing, the scripts that you can see in case you want to try it out on your own outside the Axelar example repo, or you have an ongoing integration that you want to test out. You can quickly just check it out and then you'll be good to go. So I'm going to wait a bit to see if you have any questions before I proceed. Oh yeah, this is what time. Thank you for joining. Yeah, so I didn't quite get your question, Satoshi. Chain selector, I didn't quite get what you mean by CCIP chain selector. But then here also you can select chain. If chain selector you mean is specifying the chain that you want to interact with, then fine. You can do that directly here, which you can see that I was able to select like different chain available to me locally. By the way, this is just 5 networks supported locally. This is not the network, the entire network supported by Axelar. Today, Axelar is connected to over 65 plus chains. that you can pick from and then test with. But locally, inside this Axelar local environment, for you to test things out within chains, we just spin up 5 blockchains for you locally so that you can test out within these different blockchains. But that's not the only change. So for if chain selector you mentioned means specifying chains or like having a range of chains to pick from, then this is the answer. We have like lots more chain, but within these Axelar examples, these are the chains that we can test with. Yeah, and Sarah, yes. Axelar is quite very easy for you to test. And apart from just building, we also try to support our developers with the toolings they need to build and excel. Thank you. What else? Okay, yeah. So I think that's it. So we can keep going, like testing things out. Testing, you can see all of them. Unlock and unlock fee. Let me bring this down a bit. Lock and unlock fee, multi-chain game, multi-chain NFT mint. Like time does not permit for us to like go through the entire thing, but the most important part is that we understand the fundamentals and what you need to know about building with Axelar local development and what are some of all the options available to you as a builder. So I'm going to go back to the presentation now and round up. So now you can see that we were able to like test like what the flow looks like locally without having to do anything. So I think I can see one question here. It says, what method does it use mint and bond from source chain? Yes. So we have different methods based on your needs. Right. So let's say, for example, you have your token deployed on Ethereum and it's already deployed on Ethereum. You want to like deploy remotely on other chain and then be like canonical version of that token. Then what we are going to do for you is after deploying remotely, if you want to move the assets from Ethereum to that particular chain, we are going to lock it for you and then mint on that chain or the new chain, right? But if you have your token already deployed on all these protocol, maybe like 5 different chains, and then you have minting and bonding available on that particular token that you deploy, then what we are going to do for you is after deploying or making them an interchain token, by deploying a token manager across all of these chains. So that way you can control the token manager. What the token manager is going to do for you is to mint and bond tokens across these chains as you move them. So that way you can maintain the total supply across all of these chains without having to do any extra thing or like any extra effort. So depending on the use case and then what you're trying to achieve, what we have for every use case, we have different scenario for it. So let me quickly show that since you asked the question. So if you go to our docs directly today, go to cross-chain token transfer under interchain tokens, you see that we have like different categories there. First, we have the no code setup where you can just go through the ITS portal, the interchain token portal, connect your wallet. If you have a token already existing, then you can paste it here and then deploy it. If you don't, you can connect your wallet and create a brand new token. This is the first option. And then the second option is creating a new token. So if you want to create a fresh token, this token have never existed anywhere, and you want to do it programmatically, you can directly just do it programmatically here. So this is the option of programmatically creating a new token if you don't want to use the portal. Maybe you have like custom integration that you want to use too. So you can call the functions directly and then you'll be good to go. And then the next one is register existing token. You already have your token on one chain and you want to register it as a canonical interchain token using the factory, what we call the interchain token factory contract. Yes, that's okay. We have the option for you and we have things that you need to call. You can see this flow of how interaction happens when you try to deploy or move token from one chain to the other. So if you scroll down, if you keep scrolling, you see that you can call this function called register canonical interchain token that will allow you to register this token as a canonical interchain token. Just one function call, pass in your address, and you are good to go. So this can also be done on the portal, but programmatically, if you want to do it, this is the function call that you have to call because the portal also calls this function to do it on your behalf. But now, because you have UX you can just do it directly quickly. And then the other option is integrating custom tokens. So sometimes your token might have like custom functionality across different chains, right? If you want to still maintain that functionality across all of the chains, but because they are custom chains, all you just need to do is to deploy a token manager, and that token manager, you can connect them, that deploy the token manager across different chain, and then you can use that token manager to move tokens across. As you can see on the screen with this example where you integrate with ITS by deploying the token manager, you deploy the token manager on different chains, assign the minter role to your token manager. This is giving permission to your token manager to be able to mint your token on your behalf. So there is nothing we are doing like overhauling or like trying to take charge of anything. You need to give the permission for it to happen. And then after you give the permission for the token manager, which you only control via your token, then you can see like the way transfer process works, the things you need to know. And then once you set up token manager, give permission to it, you can just start ITS transfer immediately. Like there's no any other configuration you need to do. And then that's how easy for you to integrate your existing token. So depending on the scenario that you're trying to the use case, then there's always methods available for you to use within the Axelar. You can also check out our previous stream, particularly for ITS token or like ITS in general, where I go in depth on what are some of the things you should know and what are the options available to you out of the box. So yeah, I hope that answers your question. So another question is, can we do, okay, I think I can. Oh, yeah. So this is another question. This is the first one, method. And then this is another question here asking, can we do cross-chain on NFTs? Yeah, of course. In the example, let me navigate back to the repo. In the example here, we have repo particular, like examples particularly for NFT. So you can try it out. Multichain NFT means you can try NFT, you can try NFT linker. There are some things that you can try out, particularly for NFT. And also inside the Axelar web example, if you check it out, if you check the, okay, let me go to the browser so we can all see it. If you check, 1 second. So here under this contract, if you go to the Axelar web, you see like what you need to do to run it locally. And then you can see the examples in real time. In fact, the example like with a UI compared to what we just did where we have just terminal, where you can send message to another chain. You can send token to another chain. You can send token with custom logic to another chain. And then you can send NFTs between chains. So yes, you can do cross-chain NFTs with Axelar. Yeah. Yeah, so thank you all for joining. So we're about to like wrap up now, and I'm going to go back to my presentation. So going back to the presentation, yeah, we've done this already, but if you want to try it out, you can scan this QR code and try it out on your own. Yes, I know like you might have questions, like even additional questions after this entire stream. But of course, we are happy to support you. If you just Google Axelar support, you see this repo. Feel free to create an issue, suggestion, or like complaint. If you have any experience that you don't find okay, that you want to share with us, we're happy to take all of those feedback. And just drop the issue. We get notification instantly when you create a new issue on this repo, so we'll be able to answer all your questions directly. And of course, the Axelar examples, once again, you can scan it if you want to check it out. And I need you all to like check it out, try things out on your own. If you run into any issue, please let us know. We'll be happy to help you. And then thank you once again. My name is Idris Olubisi. Thank you all for joining today's session. There's this QR code I have here, which is a survey of 1 minute, less than 1 minute survey. Please scan this QR code and give me feedback. Let me know what you think about this workshop. If you have any other suggestions that you want us to cover, please let me know. And if you find this workshop beneficial, let me know all of those feedback. It takes less than 1 minute, trust me, to fill in. These are feedback we also use to learn from individuals, then for our community to continuously improve on the quality of things that we do and also the type of content that we create. Thank you so much once again. If there is no any other question, I'll see you guys next time. Thank you. Bye.